talking.
मेरे को रखना है.
Sarvagya Srivastati, they will be joining soon.
ठीक है, वो कितने बजे है?
17 are group members.
दो है ना, कोई दो एंटर्ड है इसलिए बोल रहा हूँ. आपके यहाँ से दो एंटर्ड है. एक सेकंड.
Upasna ji, good morning.
कोई इंडियन पर्सपेक्टिव 7 बजे. वो आ जाए डायबिटीज वाली. अच्छा ठीक है, उनसे बात करनी पड़ेगा ना. हाँ ठीक है. मैं से अभी 12 बजे बात करना. 12 बजे बात करना. 12 बजे. Yes, kindly go ahead, Dr. Kalra.
Sir, abhi 2-3 minutes, let's give 3 minutes more.
We are live on the YouTube. You start the introduction and then hand it over to Dr. Jayakishan.
Yeah.
We can have a 0-hour discussion. Yes.
Yeah, today mainly it will be first our special experts will be talking, and Mr. Chandrasekhar will be giving a presentation for 10 minutes. And after all the experts, subject experts, they have finished their talk, then we will start our interactions and discussions.
The Ashish Rakeja has also joined.
Good morning, Dr. Aggarwal.
Good morning.
How are you?
Good morning, Dr. Kalra.
Good morning. I think now we can.
Good morning, Ashish. Good morning.
So you introduce the subject, Dr. Kalra, then I will speak for 2 minutes, then and hand it over to Jayakishan. Yes.
So as we know, first of all, I welcome all the participants and our special invitees for joining today's session. As we know, since last almost 6 months now, we are learning almost on daily basis from the information we received regarding the COVID. Seeing the magnitude of the problem, the way transmission of COVID-19 is going all over the world as well as in India. Recently, there was a talk about changed mode of transmission of COVID-19. Earlier, it was mainly a droplet infection. In certain special instances and procedures, it was airborne. Now, recently, there was a lot of talk and a lot of scientists. They were insisting maybe this is mode is mainly airborne. The WHO also came out with statement. The document already I have circulated. So they also, WHO also now express it may be a possibility of airborne transmission, but still more research or more evidence yet to come. So considering that the magnitude of the problem and all these apprehensions, so this meeting was called to discuss. Dr. Aggarwal informed the Korea model, which document I have already circulated. In the Korea, in a very short time, they have a temporary makeshift arrangement, and they converted the facilities into all their ICUs into AIR, negative pressure isolation rooms. And they claim the results were better. Keeping this in my view, this meeting was organized today to discuss what in India we should do for the containment of this rapidly spreading COVID-19 infection. Now I will request Dr. Aggarwal to take over and give.
Thank you, Dr. Kalra. And Dr. Shashank Joshi, I will request you to co-chair this meeting with Dr. Jailal, because Dr. Jailal from Tamil Nadu and Dr. Joshi from Bombay, because both of you are getting large number of experiences as far as this disease is concerned. Are you there, Dr. Joshi? Shashank? If he is not there, when he comes, I will like him also to co-chair this meeting. So Dr. Jailal, who is our chairperson for today, let me brief you that why this meeting was being held. because in Asian countries, the results of China, Singapore, Hong Kong, South Korea, and Taiwan, they are very large, small number of cases, and they have very low mortality. Okay. So we are, Dr. Shashank, are you here?
Yeah, I'm here.
Shashank, you are going to co-chair this meeting with Dr. Jailal today.
Yes.
So you be here and listen to it. So the purpose of this meeting was that we were looking for data from Asian countries, and we saw that New Zealand and Australia have a different mortality. Then we saw India, Pakistan, Bangladesh, Nepal, Sri Lanka has the lowest mortality, but other countries have a similar mortality. And this mortality was now Thailand, Indonesia, Malaysia, then Singapore, then South Korea, Taiwan, China, they have a similar mortality. And then we found the group of Iranian country, which has a very high mortality. So we are looking for a common factor. What decides the mortality? One of the common factor was presence or absence of AII rooms in the triage, in the emergency room. That means in your emergency room, if you have two facilities available, one is the viral load, which is a CT value of RT-PCR. If the viral load is, if the CT value is low, the viral load is very high. So if you have one information in an emergency room where the first on contact patient is coming, and if you have a negative isolation room, then cross-infection amongst healthcare workers is zero. And then you are shifting those patients into a COVID and a non-COVID facility. So we want to come out with our understanding. Should we make CT value mandatory? We write to ICMR and the labs are not cooperating. They say, unless ICMR tells us, we will not disclose the CT value. That's one. Second one is we are talking about is what is the difficulty in mandating presence or absence of AII rooms in India? Why can't every ER in the country be made into AII rooms, for which we have two experts who are the technical experts who are going to talk to us. Is it possible? If yes, what is the hitch? Why a South Korean government can mandate, and within 15 days, all the facilities in the country were converted into AII rooms. I spoke to China, I spoke to South Korea, I spoke to Taiwan, I spoke to Singapore, I talked to Hong Kong. All these countries says the patient has to come into a AII room facility until he is declared COVID negative. He will stay in isolation air with a negative pressure. So that if that happens, I am 100% sure none of the doctors in future would die, because doctors are getting repeatedly infections there. With that mandate, I hand it over to Dr. Jailal and Dr. Shashank Joshi to chair and co-chair this meeting.
Welcome, Dr. D.N. Suresh. He's also another expert. He has joined now.
So a few comments by Dr. Jailal and then by Dr. Shashank Joshi. And then three speakers will speak, and then both of you will open it for the question answers.
Thank you very much.
Sanchita is moderating this. Sanchita is taking notes and she will prepare the minutes.
Thank you, Professor Dr. KK, for this is one of the a good opportunity for us to discuss the problems we are facing in the dealing with the COVID and get to know, as rightly said by Dr. KK Kalra, we are learning every day, the new inputs are coming. And then two important agendas which we have put forward is really a very important setup in clinical management, because as you rightly said, without the guidance of ICMR, many labs are not providing the CT value. The CT value would have been help us, because we say that the mortality rate among the doctors community or the healthcare providers community is much high, because we say that the viral load is very high. So I think we can have a good suggestion or good recommendation to the government to make it mandatory, so that it will give us a clue for us to go further. One of the very big challenge of the AII, because we are also discussing with the government on that, because it needs a lot of engineering modifications, because the ventilation pattern which is we have in the emergency rooms are totally a different pattern of setup. And the air exchanger, when we are using the 10 exchange per air, when we are using, definitely it need a structural modification. And the second, we were still using that concept of emergency casualty concept, which is not, we are not having a concept of emergency care room in many of the medical colleges. So that is again another big challenge which you are going to see. But if a consensus is arrived, the most of the governments will be also willing to take forward that issue, because the expenditure involved will not be that very high, but it's only the mindset has to come in. So the experts like this, when we are putting forward a practical and feasible solution, I am sure that we will be able to get a positive response from the government also, because that is going to make a change in the perception or change in the mortality rate which you are going to have. So with this, we are looking forward to have the experts' opinion, and probably at the end we will be able to make a consolidated statements or the white paper, so that we will be able to submit to the governments also, to pressurize the governments to take up this issue. So thank you very much, and it is very nice to have Shashank Joshi sir also with us. So sir will be continuing with this.
So I agree with you, Chairman sir, and I think Dr. Aggarwal has very nicely put it. We have two very simple agendas. One is estimation of viral load is mandatory in all viral diseases, and in COVID it becomes very relevant because the risk of transmission to people at large becomes extremely pertinent. And though ICMR is saying that there is no community transmission, clearly we know there is localized transmission, and therefore estimating the viral load has a prognostic value, therapeutic value, safety value. So I think we will have domain experts right now who will let us know, and we can come with a good position paper or a white paper which can quantify the same. And the second most important thing is the air ventilation and negative pressure systems should be there. In fact, my personal take is that right from the ambulance, which should have a HEPA filter, to the first point of care of a healthcare professional with a potential patient, till the suspect COVID is sorted out as COVID, non-COVID, we need to have a microbe-free environment in which we need to mitigate the risk of transmission to the healthcare worker. And therefore, the AI systems, which Dr. Aggarwal, I congratulate him for this endeavor. And as my co-chair has said, we are looking forward to our three experts who can actually guide us how we should tell and write out a paper where we can compel both our central and state governments to ensure that this is mandated in the healthcare setups. And I also agree with my co-chair that this concept of emergency room has not evolved in India. We are still having the so-called casualty concept. And I think the casualties now need to be equipped better to handle this type of situations. And it is important that many of our casualties or so-called emergency rooms are overcrowded. They are poorly ventilated. And because they are overcrowded and poorly ventilated, particularly public hospitals, like in Mumbai, we have this KM hospital, Sion hospital. You must have seen them on television. They are so overcrowded. And virtually now, the whole staff has probably had COVID. And this is not something which we are happy about. So it is important that these guidance or recommendations will get. And I also agree with my co-chairman that every day we are learning something new. When COVID started, masking was not compulsory. Today, masking is that of order. Second thing is, it was the macro droplet which was important. Now we all understand the relevance of airborne micro droplets. And I think there is reasonable certainty now that it is the airborne micro droplets which are causing the havoc. Otherwise, by now, just by simple, the strategies of lockdown, we should have been able to mitigate the virus. But the very fact that we are not able to mitigate the virus across the world is probably one of the reasons is the micro droplet transmission. So I think I don't want to take too much of our time. We are here to listen from our domain experts, and I'm sure we'll have a very healthy and fruitful discussion. So I pass it back to my chairman, who will probably introduce our experts, and then or Dr. Aggarwal, and then we will take it up from there. Thank you.
I request Dr. Kalra to introduce the first speaker.
First, our domain expert is Mr. Chandrasekhar. He is a retired senior architect from Ministry of Health, and he has a vast experience in hospital building designing. And our next expert is Mr. Ashish Raheja. He is expertise in HVAC systems. Earlier also, he has contributed a lot toward air conditioning document. We have already consensus statement on that. And then Mr. D.M. Suresh. He is the main project officer, Max Healthcare Group. He is also a vast experience and he will speak, contribute toward the discussion. So first we may invite Mr. Chandrasekhar to talk, then Mr. Ashish, and then Suresh we can invite. Back to Mr. Jalal.
Good morning, everyone. And in fact, I would like to make a small presentation just to give an overview. If I been permitted to share the screen.
Ritu?
Yeah, it's been done. We have just now Dr. Aggarwal and even the chairperson has declared the engineering controls are always been very important, and that is what exactly we are going to talk about. All these days we have been talking about how to control the airborne transmission, but somehow the views were very different. Clinically, yes, lot of number of parameters which you are taking it is fine. So generally today we'll be talking about the indoor air quality, which is going to be the key matter in which we generally deal with the particulate gases and microbial. So in the particulate, we have this dust, dander, pollen, organic clumps, etc., usually handled by air filtration, and filter must be maintained to be effective. In microbial, you have a bacteria, virus, and mold, spores, etc. And this is also where now the purification method has to be involved. And the lastly is the gases like volatile organic compound and the odors, which is molecule dissolved or in the air, like perfumes, etc. Now, mainly the technology or method to reduce risk of airborne transmission. Dilution is the best method as of now. The high ventilation rate air changes per hour control particle by removal through ventilation. Push the air from one side and take it out from the other side, but treat the air before entry and treat the air before exit. So there are a lot of treatment methods available, and that is why this is very, very, large area where the number of people are there. Instead of just getting this thing, higher ventilation rates are going to prove the better. Even we have a record that when SARS hit the country at the in the past, cross-ventilated wards never had any problem, and all the central air-conditioned people had all the challenges. So this is one of the important that where how you can maintain the air changes. And pressurization, anyway, you are aware that negative pressure in isolation room, we are doing it. And filtration, use of pre-filter, microwave filter or HEPA filter. Now what happens is actually we stop here. We are not going ahead in the treating. In these filters are the one which is going to have a colony of pathogen because that is going to be trapped there. So what you have to use is purification. That is, you have to destroy this infectious agent in air through exposure to UV radiation, that is ultraviolet germicidal irradiation or photohydroionization or HEPA MD or even plasmarization. So HEPA is the high efficiency particulate arrestants. MD is microbial destruction. So unless you include this purification factor as a mandatory, these kind of viruses and the infection rate is going to have continuously affecting you. So in the airborne infection isolation, I will be talking about this only, that patient infected with organisms spread via airborne droplets. So this is the COVID, measles, TB, chickenpox, etc. Generally, we have been using for TB patient as of now. Now it has become mandatory for all of them. This is a negative pressure isolation or AIA where air should flow from corridor to isolation room to prevent contamination. Anteroom provides an airlock between room and corridor, maintain continuous negative pressure, and separate exhaust system is placed to remove at least 15% more air than of inlet. Supply should be from the ceiling diffuser and exhaust from near the floor, and greater 12 air changes for renovated room, and MERV 14 filter is minimum on the supply side and 90% dust spot test, and HEPA on the exhaust side. and recirculation discouraged if HEPA filter is not used. And generally nowadays, even where the tier 2, tier 3 cities, when this becomes a challenge, we throw the air through the sodium hypochlorite solution tank also, so that at least we are able to throw the air out, which is neutralized. So this is the typical layout of a isolation room where we need an anti-room and an isolation facility. And nowadays, the various wards which we are dealing, and in this, we have these kind of a pressure that almost ward or toilet is the highest, and these are the where we have at least 12 times per hour. These are heavily contaminated and contaminated air. And patient and buffer room, these are the semi-contaminated where we have a 6 times air changes or minus 10 Pascal. And treatment room is around semi-clean area where we have the minus 10, and medical staff corridor or other area, we have a minus 5 Pascal. This is the general standard. Even ISHRAE or ASHRAE, they are recommending it. The design of the room will have to need modification when you are making a simple single room. The patient entry room is this way, but staff flow entry is from this side. When they come out from the other route, and they have one biohazard material dumping area. So this becomes another barrier. So this is one of the modification one need to carry on in a normal private room, which we are doing it for highly infectious disease. And as you are aware already, this is a very popular thing in terms of this thing. And particle dispersion infectious patient, this we also have studied. You are all clinician. Here we have already seen. Earlier also we have during our we have recommended that droplets evaporated to become droplet nuclei, and they fall with the gravity or drag force or airflow, and droplets are swept by the air motion and fall due to gravity. Their fall is resisted by a drag force, and ballistic trajectory of the large droplet from sneezing mode, and these droplets land on a surface and dry and to become a desiccated, while bed making activities eject dry particle into the air. This is another seriousness when we did some study, and we realized that when there was a lot of talk going on between the airborne or not airborne, that is the time we realized that what is the parameter. Then we decided that at least use the ultraviolet germicidal irradiation, the known technology in the duct or in the coil, and even upper UVGI, which you used to use all in the TB wards, etc. in earlier cases, because you have to be very careful that UV radiation should not have any exposure directly to any humankind for the safety of the skin or the eyes, etc. So it has to be very carefully handled with the help of the expert, not that anybody can put in UVGI as such. And we use this UVGI setup in the air handling unit. By putting this air handling unit, the UVGI, we try to eliminate or kill what we wanted to do is. And presently, we have also this AI aircon system where we have put a central cleaner. And we worked out little experiment on this and try and tested. And we were finding it's a very satisfactory result. And one thing which we always wanted, that whether it can be applied to all the existing system and also the new one, so which is possible, and that is how this can be customized. Now, when we did the test, we had done the virus kill rate of 99% of H1N1, bacteria kill rate 100% of E. coli, or PM 2.5 reduction to 90% efficiency, or volatile organic compound reduction. So all these, we have seen that how these things are going on very well. And this is where we thought that we should have a trap and kill technology, which should have a 3 level, that is impingement, polarization, and agglomeration. So filtered air particles filtered up to 0.1 micron size. And this we found that stage 1, you have a graded HDPP long-lasting filter for effective PUM10. Then you have a stage 2, which is polarization. Now this electron charge or a polarization needle effective on microparticle makes them thicker, so that in the stage 3, you are able to trap them and kill the germs. So this is dual polarity and no arcing. And Another system which came out was the plasma air disinfection, where bipolar ionization unit can be inducted. I was also asked to help the railway coaches how to handle the air conditioning system, because there are a lot of challenges where we are a team of people along with the air conditioning experts from ISHRE and others are working on it, where we also found now when we are working on all these solutions are a number, but they have to be cost effective also. Then we also realized during earlier stage, Dr. Aggarwal used to say, also think of smaller institution or the nursing homes and people where these people can, use their this thing. So we tried and tested, and we got a very good result for our split type air conditioner and also the cassette. Even when you are seeing it, that blue color, we tried and seen that there is no ultraviolet rays comes out of it. We have done that testing also, so that should not be harmful. And similarly, this smaller model of plasma related things are available where one can keep it in the room. Now you have to understand one thing. When we use such model, the problem is that we close all the doors and windows, then the CO2 level goes high. Air changes is a must, and that is where you have to induct a fresh air induction with the filtration technique. HEPA MD is the one which is high efficiency particulate arrestance with microbial destruction. It has a 4-layer. That is, first is the exposure to a thermal plasma, then second is captured by electrical media, third is molecular filtration, and fourth is molecular trapping. So that 100%, like first level, you are getting a microbial destruction. Second level, biological decontamination and higher efficiency particulate arrestance. Third is a catalytic conversion and molecular trapping. And these are available in different models. So as per the need, one can set up whether a mobile air decontamination unit when there is a unit is small, or when there is a ceiling mounted, or the mobile protective environment. Sometimes a burn case also with a highly infectious also, they can be controlled within that parameter, and the ceiling diffuser system is also available. This is another one where we have a pre-filtration and high filtration and the biooxygen system. So there are variety of filtrations are available. So the benefit of the air disinfection, proven protection against the transmission of airborne pathogen, and proven benefit to the healthcare sector, and effective against MRSA, norovirus, etc., and effective against unpleasant odor. So even current CDC guidelines recommend negative pressure room with anti-room for patient, hemorrhagic fever, and also HEPA respirator by person entering in this room when the patient has a prominent cough, vomiting, diarrhea, hemorrhage, etc. Now, face shield or goggles will help to prevent mucous membrane exposure to potentially aerosolized infectious material in this situation. So use of now to disinfect, we use the COVID robotics. And these robots that use for contagion and virus control are able to generate high concentration ultraviolet rays, and they destroy contagious disease. These can be used most effectively in decontamination or detoxification of COVID healthcare facilities, ward, transport facilities, and the like. So this can be, with the remote, it can be moved around to the place of usage, and that entire place can be disinfected. Even the wards or your toilets or other thing, we have these striking robots, and even the micro solution where you are in a position to sanitize them, including even your wheelchair. So UV technology becomes a very important issue. So thank you very much. So this is what I exactly wanted to share with you. Now I'm leaving it to the experts.
Thank you so
Next
much.
speaker, Dr. Kalra, next speaker.
Mr. Ashish, you can invite. Mr. Ashish Akheja ji.
Yes, I'd like to also make a small presentation if it's okay.
Yeah,
Yes,
please.
go ahead.
Ritu?
So thank you, Dr. Chandrasekhar. I think you're a doctor in air conditioning also. The way you presented, it's amazing the kind of knowledge that you carry, and you made my task simpler. So I do want to talk about some of the aspects that Dr. Chandrasekhar covered very briefly. And he's rightly pointed out that the technologies are available. There's a lot of work which has been done by ISHRE and ASHRE in this area. And those documents are well available to everybody to refer. Now, what's very important when we look at the recommendations that have come out or the solutions that are being talked about, they all go down to the fundamentals that we have known for very long. So the solutions which are there typically are the ones which we have known for long. Now, let me first start with the fundamental and then go to the subject itself. I think whatever Dr. Kalla, you also shared some backup papers and all. When we look at them, they're talking exactly the same thing, that in the airborne transmission route, the small droplets are where the challenges are. They are the ones which are getting airborne and being carried by the air conditioning system, and possibly present a risk, which WHO in their document, technical document, has also said that more work needs to be done in that area. On the larger droplet side, they've mentioned that even though the droplets, they go on the surface, they can be there for a couple of hours or 2 days, depending on what kind of surface it is. But the challenge remains that the prime source of transmission continues to be the face-to-face or the larger droplets which are going and falling onto the person in front. But as there's a risk being talked about by the airborne transmission medium, which typically gets carried in two ways. It needs a substrate to get carried. And we talk about the atmospheric dust particles, or the PM 2.5, PM 10 that we've always been speaking about, they being the substrate, or it could be the aerosols which are helping in the transmission. So if you look at the ASHRAE, which is the Bible for all the air conditioning systems which are designed in most part of the world, they recommend the following 7 strategies. Dilution, which is where the addition of the outdoor air comes into a picture. The second is the airflow patterns, the positive pressure, negative pressure areas, and how the air is flowing. So it's not only the positive pressure, negative pressure, but also there is no haphazard movement of the air inside the occupied space. It needs to flow in a certain pattern. The third is the pressurization that I spoke about. The fourth is temperature, then relative humidity, filtration, and finally the other strategies like the UVGI and all. All of these strategies help to reduce the bioburden, as we say, in the system. But at the end of the day, they are helping us to minimize the transmission. Now, in terms of temperature, relative humidity, there are already guidelines which are talking about elevated temperatures and the elevated relative humidities. But still, keeping in mind that the microbial growth is not encouraged. So a good temperature between 24 to 27 or 50 to 70% RH are being recommended. Now, there was a last time when we had a similar discussion, there was a talk that when the doctors are wearing a PPE kit, they've been requesting for a lower temperature. Yes, that is possible to be done. But what's important is the ventilation rate also is playing an important role. Ideally, as Dr. Chandrasekhar was saying, we'd like to have an open everything where you have a 100% ventilation system. That would be the best thing to go for. But then that's not what is possible in now healthcare facilities when we are looking at minimizing the dust particles and all, because our outdoor air quality is not exactly very clean. So elevated outdoor air additions are important. The guidelines are available in the systems. I'll just come to what needs to be done in present facilities also. I'll just talk about that. But as much as we are able to bring it to the recommended levels where we talk about minimum 2 air changes per hour in any room in a healthcare environment to be maintained, and going as high as 12 air changes also in some of the, as 6 air changes to higher air changes also in the healthcare facilities. While the UVGI is being talked about as one of the areas which the healthcare industry has been using in past and continue to use, and there are plenty of solutions available. But what we are finding is there are still challenges and understanding of the UVGI solutions. Now, some of the things that are important in its consideration when we are selecting the UV lamps, that at the lower temperatures, at the cold temperature, the effectiveness of the UV also comes down in a proportional fashion. So at a let's say the UV lamps are rated at about 40 degrees centigrade. When we are selecting them at a cold environment of 20 degrees centigrade, the UV output also comes down by 50%. So if you want to make them effective, understanding of them is also very important. For its effectiveness in terms of disinfection, the intensity of the UV lamp and the time, they're inversely proportional. That means the more amount of time that we are exposing it, the intensity can accordingly be reduced, or vice versa too. And that's another area. There are a lot of solutions that we are seeing which are being implemented in healthcare and other solutions where they say you just pass the air through UV and your problems are solved. That may not be the case. UV can be used for disinfecting the surfaces, but if you want to clean the air, we need a higher air change rate and we need more time of contact. And to get that more time of contact, it is not that easy in a system which is existing and where the air is traveling in the duct for a few seconds only and being discharged. So those are areas where the experts need to get involved and look at. There are a lot of applications which even Dr. Chandrasekhar talked about, from plasma to PCO to photohydronizations and all. They're all UV based, which the UV lamp is falling on some coated surfaces and exciting the superions which are getting into the air, which is helping to killing the microorganisms, which how effective they are on COVID, that's not exactly well understood and documented. But yes, it helps to bring down the microorganisms which are present in the room. Now, filters are important, and fortunately, in the healthcare environment, we have been using, or rather, the standards have been specifying good filters, starting from basic MERV 13, MERV 14 filters, and going as high as the HEPA filters to be done. And they are very effective in catching the and removing the coronavirus, the COVID-19 also. It can coronavirus can take care of it. But having said that, we understand that it's not possible to put HEPA filters everywhere. There are constraints with the existing systems. So it's not like that if it's no HEPA, the problem is like nothing can be done. A good filtration, which may not be HEPA in an existing setup, can also at least help to alleviate the problem, if not completely remove the problem. As you can see, the HEPA may have a filtration efficiency of 99.95% and going to 99.995%, but lesser than that also, we are talking of a filtration efficiency from 85% to 99.5%. So just HEPA and HEPA alone, I think, yes, it's desirable to have that, but is that the only solution? No. Again, then experts could help you to look at those areas. The ISHRAE-ASHRAE guidelines also talk about the mechanically ventilated spaces and evaporatively cooled spaces and how to handle them. Since these spaces work on 100% fresh air, they are relatively easy to take care of. But again, the dust particle in the air remain a challenge. A lot of time, the air purifiers are also being talked about, which can be a good addition to a room because there's a very small air change rate which is taking place, but they not be the ideal solution for preventing the spread of virus. So I'll just bring it to the end of the ASHRAE recommendation again. And like we spoke about the enhanced filtration, go for a good filtration in an existing setup, closer to HEPA. HEPA desirable, but then HEPA is not the only way to go because we do have challenges with the existing systems and how we do that. Increasing the fresh air, increasing the air change rate. Upper room UVGI is a great proven way of handling these microorganisms. They can be looked at. Good directional airflow with good exhaust working there, temperature, humidity control, all of that will help alleviate the problem in a big way. And I think this is what needs to be done. And I'll just sum it up with the slide. And because I was reading a lot of documents over past few weeks, and to me, what happens is when you have a new facilities coming up, they're relatively easy to handle. Follow the guidelines which have been there, because we are keeping on emphasizing at this point of time also, all we are saying is if the hospital or the healthcare facility has followed the basic design guidelines, the challenges are little. Pressure relationships are most important, and more than that, testing of the pressures, because over a period of time, as the filters are becoming clogged, there's a change of pressures relationship which take place. You need to take that. Dedicated air handling units for each space is an important aspect, which is generally forgotten by the, or rather, because of the space constraint, we keep tucking the air handling units in the ceiling or trying to combine them for various spaces. I think the current crisis has shown us these shortcuts don't work. We need to have a dedicated air handling units for each of the space to segregate the airflows. The importance of the ducted return air systems have got emphasized here. Again, trying to compress the floor-to-floor heights just to get more floors, getting around the NBC provision of a height limitation. I think it's come out that there is no shortcuts to the ducted return air systems, especially in the critical care units and these areas. How we locate the exhaust, how we treat the exhaust air is again a consideration. At the highest point, are we letting it out, or are we treating the exhaust air, needs to be seen at. I've been a big promoter of or operation theaters with a variable fresh air. That means that we should be able to take it to minimum 4 air changes per hour to a maximum 20 air changes per hour. And I've always advocated that it helps based on the procedure, one can change the fresh air rate which is being added in the room. And again, this crisis has shown such modular designs are the need of the day because we don't know what is going to strike us next, and medical facilities need to be ready for these unexpected conditions also. We saw some of the examples of recirculation air handling units being used for the patient rooms. I think again, when we are trying to convert them into isolation rooms, each of the patient room or the IPD areas, we found such systems lacking, and they need to be carefully examined going forward. And finally, the isolation rooms were always, it's very interesting. I may be designing 40, 50 healthcare units. Most of them, we still don't know till the point the final designs are being done. Are we going for positive isolation room or a negative isolation room? It's all left very vague. I think the design and the importance of the isolation room, including the ante room and all, have come out. Finally, to end it, for a temporary facilities which are required, which are need of the day, one of the good solutions is to move towards the higher fresh air rates. If we are not able to put better filters into them, of course, we can upgrade the filters to easily to MERV 13, MERV 14 without any challenge. There are good electrostatic precipitators and all which are available, which do not create any additional resistance to the airflow. Just by removing the existing filters, you can easily retrofit within a few days' time. They can be retrofitted. You can increase the fresh air quantity, make the airflow directional, make sure the exhausts are being correctly being put, the negative spaces are being created as per the guidelines which are available, and we are able to maintain the pressure relationships. One last thing I like to end this talk is that I was asked in one of the talks that once you've got a good HVAC system, is everything taken care of? Is the doctor safe? No, HVAC systems are not the substitute for PPE. Remember that they are only helping to minimize the transmission. At the end of the day, the kits and all play an important role. So thank you, doctor. I'll leave it here. Doctor, you're mute. Dr. Kalra.
Now, Mr. Suresh, please give your views. How you are doing in Max Healthcare area?
Good morning to all. Thank you very much, Dr. Aggarwal, Dr. Kalra, for inviting me to be part of this very nice conversation we have. You have heard two really big-time experts, Dr. Chandrasekhar and Mr. Rakeja. I think once they talk, probably rest of us has to just keep quiet because it's just nod our head. Because most of the things what they say doesn't have questions across. I've been fortunate. I've worked with both these gentlemen and I've learned a lot from them also. Well, I come from a different perspective and a different challenge I face in a day-to-day atmosphere. I mean, in a day-to-day operations of the hospital. Because one of the biggest challenge today we are facing in almost all hospitals, probably across the world, maybe, but more so I can be more realistic about what we face at Max, is how do we handle COVID and non-COVID patients? Because we are getting both COVID and non-COVID patients together, and we sometimes don't even know who is a COVID positive, because there are many people, as per the WHO's recent thing, almost around 40 to 50% people can be asymptomatic or pre-symptomatic. We have faced this. There has been incidences where a patient has been wheeled into a cath lab for an angiogram or something, and later the patient turned out to be COVID positive and the doctors got infected. So these are all a common thing which we keep hearing. So that is first challenge I feel, as to how do we segregate COVID versus non-COVID when it comes to emergency, because they walk into ER. ER is a common place where everybody walks in. So we really sometimes are at end of our wits to find a solution as to how do I contain or control this. I think still we haven't found a satisfactory answer to it from engineering point of view. We have found certain things which is more social in nature, I would say. That is, we try to screen them before, we try to check them before. These are all most of the social engineering rather than any engineering methods to segregate. So that is one thing probably I expect all the experts in this field to work on, as to how do we really handle this particular case. Is there a way we can segregate this so that the non-COVID patients in an ER doesn't get infected? And this is a close reality. We have same problem when they walk into our lobbies, and more so is when they are wheeled into OT. The biggest challenge comes is when we say we create negative pressure, positive pressures, etc. How do I create my OT into negative pressure? Now, there is a major concern of infection control. The purpose of keeping OT positive pressure is that we don't want outside infection to go. The sterility of that is at highest level. And now if I go and make that into negative pressure, the whole concept of making OT a sterile zone gets compromised. So this is another area where we don't have an answer and we are struggling with it. What we have done, I can explain. In our hospital, what we have done is we have dedicated one OT exclusively for COVID patients, and we screen them off. We have separated it out. We have a separate AHU from the day one. We have separate AHUs there. So we have separated it out, and even the common corridor which is there in the OT has been barricaded. Though it is a compromise from fire point of view, because I'm not supposed to barricade a corridor, because that also serves as a fire corridor. But we are taking a little bit of a risk, but we are making it airtight, and still we create one OT into a COVID OT. Now that is when I know a patient is COVID positive and I'm wheeling in that patient for a surgical intervention. But when I don't know a patient is COVID positive or not, we just have no answer as to where to take the patient, whether to non-COVID OT or to a COVID OT. So now this is some engineering intervention is required here as to how do we convert them or how do we quickly change over this. But I know it's not as easy as I am talking about. Now, coming to a few of our practical problems, what we faced. One is about the UVC, UVGI, what is being advocated by many. What I face often is, I was a little bit skeptical about how UV can do, because it is nothing more than sunlight. Because sunlight, if I put a cover, cannot penetrate into it. Like if I shut my doors and sit in a dark room, sunlight doesn't penetrate. So when that is the case, how can UV penetrate into a surface? So we did get this robo, what Dr. Chandrasekhar was talking about, and we wanted to experiment. We put it in a room. The manufacturer advised us to put the UV for 15 minutes to get all points of germs and bacteria, virus to get killed, including COVID. We used this UV for over 2 hours. And we left the whole room for the manufacturer to do his experimentation. What we did is, in the room, we placed certain squabs of infected bacteria, infected viruses, molds, and all kinds of things what we feel UV kills. The unfortunate result of this experiment was nothing more than yeast and mold got diluted by UVC after an exposure of over 2 hours. So I think somewhere even these kind of things is going like Ramdev's coronal. No, most of it not even getting peer review. Most of this is not even getting experiment correctly. I have spoken to several manufacturers. One manufacturer told me, how did you arrive at that this will work? He told, sir, you please Google and you can download all the information. Now that is the level of research knowledge they are possessing. Somewhere I feel that it's kind of a make a quick buck or make hay when sun is there kind of a story. A lot of manufacturers coming, and unfortunately we also get dragged because we're under pressure to make something work and we are pushing into it. Same thing with the hypochlorite solution. A hypochlorite thing was put, it is nothing but swimming pool water. If swimming pool water can kill COVID, then probably all of us can go and take a plunge in swimming pool. So it doesn't work. I think we should just probably move on from this and see how we really work in an existing setup. When we go for a new setup, everything is possible. We can make probably whatever no experts suggest. But how do I operate this in an existing hospital is my challenge. So in this, we did few things, which, of course, I think there was some interaction with Ashish's team also earlier on these aspects. What we did is, basically, we had challenges of where do we put our COVID patients vis-a-vis our non-COVID patients. So we segregated the floors. Within our hospital, almost all our hospital has separate floors, which is a COVID floor and a non-COVID floor. Now, in the COVID floor, what we created is we isolated all the TFA systems of that, so that it is not linked with any other system. Fortunately, we had a system like that because fire doesn't permit you to link more than one floor. So we did that. And we used a toilet exhaust system. Within the toilet exhaust system, we introduced another inline fan of about 150 CFM. Now, due to all the losses and the friction pressure, etc., in the duct, it could deliver only around 120 CFM. Now, we had a fresh air of about 60 and 120 CFM of exhaust. It created a negative pressure of -6 Pascal. WHO says you have to have for N grade, that is N level isolation of -30 Pascal if you don't have an anti-room. I don't know how do we achieve -30 Pascal when my air conditioning system itself in a room is not more than 500, 600 CFM. And if I exhaust out 300, 400 CFM to achieve 30 Pascal, maybe someone like Ashish could explain me and help me out as to how do I condition my space, which is a big challenge. That is, my FCUs has to increase. The size of the FCU has to go much higher. Probably that is the answer. But in an existing setup, probably that is not feasible. So today we have negative pressure for sure. Our air doesn't leak out. We're using toilet exhaust, and through toilet exhaust, we are exhausting out the air through the, it is going to the rooftop, and from rooftop, it gets exhausted out. And in few places, we did introduce HEPA filters. So through HEPA, it is getting exhausted out. Our rest of the fresh air is a normal fresh air that is coming, which is fading into the corridor, into the room, and the corridor remains positive. Now here, whenever I do this, whenever I keep recommending this to my engineers to do, I always keep worrying about how do I contain fire? Because the fire norms is very clear and which is very relevant also to say your contained spaces, that is your room, etc., which doesn't have an additional exit, should be positively pressurized. In case of a fire, the smoke should not spread into the rooms. Now, yes, fire, we can prevent fire. Corona, we cannot prevent as of now. So we're taking the risk saying that probability of fire is very low. But in case of a fire, there is a huge challenge as to how do we manage this two things of positive pressure required by fire norms and negative pressure required as per the clinical requirements or as per the corona requirements or whatever positive, negative pressure aspect. So this is another thing where we need to find an answer. Now going forward, we are also introducing in one of our hospitals as an experimental basis. Again, we are working with Sterling and Wilson. They have a hydroxyl ions, which Ashish was also talking and Dr. Chandrasekhar was also talking about. We are putting in one of our ER at Saket. Probably it will be installed in about 3 to 4 weeks. We have placed the order and it's getting manufactured and all. So we are expecting it to be done in probably by sometime mid-August or towards the end of August. Now this, if it works as they have explained, it is also a combination of UVC and a hydroxyl ion which is injected into the air. Now still, the theory of how hydroxyl will oxidize or ionize the virus and the RNA of the virus, there is no data. There is no technical data, and it's being experimented or done on few other bacteria earlier, and it has worked. But in real time, we don't know. So that's the reason we are installing it to be sure that it works. And the cost of this is coming out as of now is around 20 rupees per CFM. So it won't be a very cheap solution when we go for a larger setup. But yes, if we are looking for one or two areas where we would like to touch base, it will not be a big money. Like in our ER, it is around 8,000 CFM HU. So it's costing us around 1.5 lakhs. And little bit of more interventions in terms of how we connect electrical cons and all. I think the whole thing will be less than 2 lakhs probably, which is not a big money there. But now if I want to extend this for all my HUs or all other areas, probably the number will get exponentially high, which may not be a very feasible solution. Now, when is for ICUs, what we have done for isolation purpose and creating the negative pressure is, fortunately, we use the smoke extraction fan, which is there for from the fire point of view. So we are running the smoke extraction fans there and creating negative pressure. And because smoke extraction fans are large in size, we are able to create a negative pressure of minus 15 pascals there. But again, when we do that, air conditioning of the area does get affected. So we are keeping our water supply, chilled water supply at maximum, and still we'll be able to get, we're able to achieve temperature of around 25, 26 degrees, and dropping it less than that is always a challenge. So, and as you know, doctors and all the medical staff are in PPE, which is hardly they can breathe through the PPE. So that's always a complaint from them saying it is very stuffy and very humid, especially in these months when humidity otherwise is also high. But we are managing the temperature of 25 and humidity of around 60 compared to 100% RH outside is still manageable. So they are being convinced that this is the best that can be done and they're managing. But at the end of the day, a comfort level of 22 degrees and getting an RH of less than 50 that they should feel inside, in spite of the PPE, they should feel it inside, is still a challenge. I probably, again, some more research, some more experimentation has to be done on this field. Now, for other thing I would like to highlight as to what we have done is about transporting patients, because once we bring the COVID patients, there is often diagnostic interventions that has to be done. They have to be taken to a CT, X-ray, or an ultrasound or something like that. So, though of course ultrasound and X-ray can be mobile, and we are doing that mobile, but I can't make a CT mobile. So we use a covered trolley, which is a ventilated trolley. So we use that to transport the patients to any such interventions or to an OT in case of an unfortunate surgery or something to be done, or for dialysis, of course, we do bedside. So these things we use, and then we use what is known as a red corridor. That is, whenever the patient has to be moved in, we alert everybody and the entire corridor is closed for all other public movements. And there is a team which comes disinfecting the whole area behind them. And again, when they go back, it is disinfected. And for the entire duration of the movement of whatever, 20 minutes, 30 minutes, the traffic is virtually closed. So we call it as a red corridor. And it's just more of a management rather than an engineering intervention. But at least it is helping us in preventing the spread of the virus beyond a point. So far we have found it successful. I mean, at least we have been, I don't want to use the word successful. We have been somewhat satisfied with, it has not gone beyond the bounds and it has not been spreading everywhere. But yes, still there are a lot of shortcomings which we need to address. And as of now, I don't know whether technology has really evolved to it, because everything has been sudden as far as corona is concerned. And I think all of us are grappling with the thoughts and ideas. Hope we will get through some better ideas in the near future. So that's what I wanted to share. I mean, I don't have any presentations or anything to share. I hope I made sense. Thank you all. Thanks. Thank you, Dr. Kalra. Thank you, Dr. Talwar. And thanks to all the participants.
Thank you, Mr. Suresh, for wonderful your efforts you are doing at Max Healthcare. Now over to our chairman.
Shashank, sir, you can give your input, sir.
So I think all our three experts have given us an insight from the engineering perspective, their problems, their challenges, and their solutions. I am a little disappointed from what Mr. Suresh is saying, that the evidence base on this is not very robust and strong. And I want our other two panelists who are also domain experts to probably comment on what he said, that except fungi and molds, really their antiviral activity is not up to the mark. And I think this is a very contentious area, and we need clarity and evidence base in that direction. So probably I'll ask Dr. Chandrasekhar and then Ashish to respond to what Mr. Suresh was saying, that at best, if it is only going to hit a mold or a fungus or a yeast, but its impact on bacteria and viruses may be there, but we don't have a systematic evidence base. Is there any way we can study this? Because we have hospital environments, small nursing home environments, where we actually can do some of these cultures and study this in a research mode. And secondly, currently, is there any system which is completely, biodecontaminated, where you can say beyond reasonable doubt, which is applicable and reproducible in a healthcare setup, small, medium size, and large? So, I mean, I know it's a very broad question I'm asking, but I think the first thing is the evidence base. So we can start with Dr. Chandrasekhar and maybe Ashish after that. How do you want to respond to what Suresh said, that, the basis of evidence base cannot be a Google search, and how do you respond to that?
I really agree with Suresh, because for the reason, when I was experimenting with number of agencies when they were coming, I have even gone up to the extent to see some guys are putting a cellophane paper on tube light and trying to tell them as a UV. The commercialization aspect and insensitivity, I'll use that word with the commercial parameter, is gone into the, when we all expert talk about UV, all these manufacturers jump into the, commercial bargain. In that process, we are really not aware which is what they claim is true. What Mr. Suresh is saying, I had even seen and verified some certificate where I could see the cut and paste in the font size. When you see that itself, you feel that the certificate produced is also not genuine. So there are few companies, but the problem is that is related with the cost. UV and these technologies are very, very expensive also. Like you said, that decontamination, that robo which you are using, I don't know whichever company you use, the robo itself cost around 57 to 75 lakhs each robo. It's not a, just a this thing which can be brought in. Second thing is, rightly said, that these are all from the abroad and straight away brought as a marketing gimmick, and they have not really seen that the Indian condition, what are the kind of a thing. So we are in the process of experimenting and doing this. That is the reason when somebody asked and said that we kill this. So he said, tell me the kill rate, and kill rate in terms of time also. Like you said, they say 15 minutes and you are taken 2 hours and still you don't get the result. So then I had requested our NIV lab at Pune and our this thing where we have a biosafety level lab 3, where we can tell them and ask them that you send and see that how these kill rates have been justified. I agree that they are already working very hard over the other problems, clinical problems. Therefore, our engineering parameter takes a little backseat. But still, I'm insisting, because being in the ministry and knowing people in person, I'm trying to tell them how important is the environmental condition rather than just the blaming the clinician for the success or the failure of this situation. One is that I agree with you, but I think that is why from UV, people have shifted to plasma. Now, plasma becomes much more expensive comparatively, but we are working out how you can bring down again, this is a Japanese, but the Japanese technology is come much closer and better. So that is one option where I could see that the things are much more effective. With this, these are all the paper and research and the interaction which I am doing. And second thing which you talked about, the fire-related issue, we have 2 options. One is, if you remember that in health ministry, we have also developed a guideline for the fire besides your NBC and other thing, for the reason You have to understand that everything cannot be evacuated. Everybody cannot be evacuated totally into the hospital area. You have to bring them in the same level in some safer zone. So two things, particularly in your operation theater, etc., wherever there is an assisted evacuation, you are very much aware that it is not a general evacuation that any public is going to run around and look for the egress. It is an assisted evacuation where the staff knows which is the nearest egress. So accordingly, there are certain relaxation. And also, when ISHRE was finding out the solution for making a OT, a working OT into, the negative pressurized, and also came up with one more the thing which WHO also has came up with these documents, where by putting a anti-lobby, which actually acts as a barrier, still you can function with your positive pressurization. There are a lot of detailed analysis is there. It is in this forum, we cannot just talk, we can talk about conceptually, but it is there. But definitely your COVID area has to be segregated through a lobby. You cannot just same corridor cannot be giving an access to your operation theater. And thirdly, like I have, if you remember, we interacted during the Ayushman Bharat also, COVID hospital or COVID unit has to be a separate building. I'll just share one example. When I was in Republic of Guinea, when Ebola erupted and we were setting up from the ministry side 200-bedded hospital. So I happened to visit. There, the pre-triage area, once you have seen that there is a symptom of COVID, Ebola, they will not permit him inside. They will straight away send him to the dedicated COVID hospital. Similar principle we may have to, but Government of India has made it very clear. They have made 3 levels. First level is just a isolation. Second is with the oxygenation. What you require is actually the ICU facility, which are very minimal in percentage. Actually, what happens, everybody is rushing towards your hospital, then obviously you have to have a asymptomatic case or anything. You have to take all the precaution. So that parameter also has to be doubted. So this is a policy versus entire situation. That is why Niti Aayog and Health Ministry, when we worked out this 3 classification, we made it very clear that majority of the people get at the very first level in isolation case. Second one is the oxygenation, and the third level only gets into the ICU kind of a facility. So I think whatever you are saying, it is not 100% satisfactory, but still a lot of things is happening because there are a lot of question mark, and every day you emerge with something new. That's just thank you.
Dr. Chandrasekhar, just a quick question, and then maybe Ashish can join. You mentioned very rightly the home quarantine, which has become an order of the norm, and 70-80% of people can actually stay at home. Any quick guidance for home quarantine, for air quality, the air conditioner they should use? Any quick home guidance? Because you see, this is all hospital. We all know hospitals. We'll go back to Ashish for his comments. Very quick, 1 line or 2 lines on home.
I had just shown you one slide in which useful for home. One is the cassette and your split AC where we can induct UV. And second, a small portable unit where it has a plasma. So it will take care of that particular room or that particular this thing. And these have already been defined with the total square feet of area they cover. So accordingly, you can take a note of that.
And these are available freely.
Yeah, these are available, and it can be happening within our, existing system. You don't have to do a major change because we are continuously working with some of the industry people. They keep coming and telling, I said, these are all okay, but I need only problem what Ashish also has mentioned. Whenever you close down everything, air change is essential. So that also part has to be taken note. And there is a solution for that also, how you can make a small, air to be pushed in with a little filtration. That is also possible. These are all residential, and nowadays, even in the IGBC, we help them that if you are able to do it as a wellness rating in your real estate houses, etc., as an inbuilt also, that they get a ready for that. And these are all happening. Nothing is we have to bring in from anywhere.
Perfect. Suresh, you were saying something, and then we go to Ashish.
You have to unmute.
Suresh, you have to unmute.
Yeah. Yes, I mean, what Dr. Chandrasekhar said is, yes, there are things are going on and working. Just answering one question, what you asked about what home thing we can do. We are doing an experiment again. This is an experiment. I don't want to suggest this as what can be implemented. We are working with Dyson air purifiers. So we are trying to see whether their HEPA filter and air filtration system can improve within a confined space the quality of air. We are doing an air culture pre, post, and almost when it is working for every 2 hours or so, we are trying to do the air culture and check. Currently, we have just started it. Maybe in about a week or 15 days time, we will have some answer whether it really works or it doesn't work. So that's one thing I wanted to add there. Now,
Ashish.
other thing I wanted to just add on to what Dr. Chandrasekhar said or have a different opinion there is, so what you said is very right that government has defined about COVID center, COVID hospital, COVID care, depending on the severity of the patient's illness. But having said that, all of them are potential infection spreaders. Even if I have a very mild symptom, I am susceptible to spread COVID. So it really doesn't matter whether I am severe or not, but I can spread it to under 10 guys probably. So the requirement there doesn't change. First point. Second, government doesn't, you said no, there should be a separate building. I 100% agree with you. That is the way it should be. But believe me, at Saket, as you know, we have got 3 buildings. We dedicated one full hospital, Saket Smart, which has 255 beds. We said we will add some 25, 30 beds more somewhere in our what we call dialysis areas and all, which is nonsense normally, which will come almost to 300 beds and allow us to use that as COVID and allow us not to dedicate any beds in other hospitals. But government put their foot down. They said, no, nothing doing. You have to give every hospital 30% beds for COVID. This is a written guideline that has come from Delhi government, endorsed by ICMR. So now when that is the case, so putting a separate hospital or a separate building for COVID, I don't know how far it is true and how far the policymakers are understanding this is still a question. That's what
that we know, because in Bombay we have 80% beds which are gone to this thing. Ashish, you wanted to make a comment?
Yes.
And Dr. Aggarwal, you were saying something.
I'll comment on both the things.
So before Ashish you speak, I have some rapid fire questions that may cover up. I want some, because I need to make a policy statement today. My first is, what about, and anybody can answer, even Ashish can answer, because one is that if I run an OPD in India Gate, which is open, sunlight, COVID OPD, totally open with N95 mask, can I do that? Will that protect in natural 100% airy sunlight OPD? Can that protect? I mean, theoretical question, rapid fire. Second is that, can I conduct camps on the open, like routine camps? All my camps used to be in a college building, in a school building. Should we recommend that in future, whenever you have camp, have them in sunlight, in open? I'm talking about non-COVID patients. So that chances of 10% of them having pre-COVID or having a asymptomatic or pre-symptomatic. And third, I need an answer very clearly about a clinic. Unless I give an answer for my clinic today to every doctor in the country, they will not open up. So whatever it is, we need to close that in a clinic of 10 by 10 or 10 by 15. What I'm going to do right away today, so that I'm protected myself and others, apart from N95 mask. So if I use a N95 mask, will the air filter an answer? Suppose they don't have a split AC, then what is the answer? Suppose they don't have a AC at all, then what is the answer? I need some basic, simple solutions before I close today. And then I need an exact answer of exhaust. How do we prepare an exhaust? And what is the average cost? Because I want to be practical before JLL sums up. I need some practical solutions, because all hospitals can afford all of you. They can afford all of you. They have big budgets. There is not an issue with them. But the purpose of calling was answer for a small clinic, busy in a basement or in a garage, because they are closed. Totally, they have closed down. Nobody is coming to their house. No, the RWA is not allowing them. Unless they bring down and say, this is what we are doing, you are safe. That solution I want. Ashish. Yes, Ashish.
Okay, so that's a googly you've thrown, Dr. Aggarwal. My own take, personal. Let's start with the fresh India Gate thing first.
Sunlight, yes. Fresh sunlight.
Yeah. Open, yes, theoretically it's possible, because Dr. Chandrasekhar also said in the beginning, earlier we used to have medical facilities which used to be completely airy and less chances of the airborne transmission of disease. Yes, theoretically it's possible. But considering the fact that you got electronics installed there next to it, because there are medical equipment.
No, pure OPD with no equipment. Pure OPD with no equipment. Only doctor, a stethoscope, and
would you expect a doctor to be wearing a PPE at that point of time?
That you have to tell me. That you have to tell me yes or no.
Well, that would be there, because the larger droplets which are being carried through the air while the distance is being, if it's not being maintained, there is a challenge out there. And in that uncontrolled environment, hot, humid, and with the air quality that we have at times, which is quite bad, it could become counterproductive also. But yes, it will definitely be better as compared to in a closed environment where we do not have any ventilation. We are running on window ACs, when we are running on split ACs. Yes, compared to that, the open one will definitely work better, in my personal opinion.
Second is a single room, 10 by 10 OPD, clinic, garage.
And let others also take it up.
Anybody? Chandrasekhar?
See, first of all, if a person is already running an thing in a ill-ventilated, we have to at least have a proper ventilation. If it is garage also, there has to be an inlet and there has to be outflow. Only thing is, what I can do is put a little control it. But frankly speaking, a good ventilation system, like just now, and I will also quote, we did it during this time in the Uttarkashi region, the kind of a OPD which you are talking about, and there was no, any kind of symptoms we saw. There, agreed that air quality was better, sun was there, and it was open and it was a camp at that time. So the highest air change, whichever you do, and if you have that AC, then I have already explained to you that you can put those UV fixtures into that and make it sure that your air is wherever, or otherwise you keep that smaller unit which will keep purifying your room, or that 10 by 10 room. That is good enough. At least at that place, that is safer. If he is going to put a small flexible plasma unit, that is going to take care of the quality of the air in that room. That will be guaranteed. That you can always check up as a pilot prior to that, like Mr. Suresh did, put some bacteria or anything or inside and try and see how it kills or it doesn't kill. So that is possible.
How much that plasma costs for a room of 10 by 10?
That small one costs around 1.5 to 2 lakhs rupees.
And that vis-a-vis plasma plus air purifier with 10 exchanges per hour, with HEPA filter, with 0.3 filter.
Yes. That, they have HEPA filter and this thing, Ashish will be able to tell, but this unit I have seen, because I was trying to work it out for railways, that in case in emergency, if you just want to make a coach, at least there, if I can put in this number of units, how I can create the entire coach into an isolation facility. That is the reason I could tell you around 2 lakhs rupees maximum. HEPA filter and added.
Ashish, what about air purifier?
Oh, sorry, I think Mr. Suresh wants to say something, then I'll comment on this part.
Yeah. Just adding to what Dr. Chandrasekhar said, we did really think we created a BSL level 2 lab recently during COVID to test, to do RT-PCR test. The room size was same 10 by 10, little bit over 10 by 10 with an anti-room of another 8 by 10. And we provided exhaust with a HEPA, and air conditioning was normal, split air conditioner was there, and that costed us about 1.5 lakh rupees. and it is going through a UV and then through a HEPA, and it has got an auto indication whether the UV is working or HEPA is working or not. So that has been found because we checked the air quality of the air that is getting exhausted out of the HEPA. We did an air culture, so there is no traces of any virus there. So that probably is a solution, though it is not a clinic, but the dimension what you mentioned is that of a clinic.
Yeah.
So from my perspective, Dr. Aggarwal, for a small clinic, as you are talking about, and I would imagine it doesn't have a central air conditioning system. It's a small window AC or split AC was installed there. There is no shortcuts to ventilation. A ventilation, that means adding some fresh air, whether it is opening the window a little bit or bringing in a fan to ventilate the room, because to reduce the viral content in the air in case there is an infected patient, I think that's the most important thing. You bring that, there's a proper exhaust. That means there's a directional airflow which is created. Number two, if you got a good air purifier in the room, which has got a, like you were also saying, and Dr. Chandrasekhar was mentioning, you have got a HEPA filter, carbon filter, pre-filter built into that with a CADR of 250 plus. And that's where Mr. Suresh was talking about trying out the Dyson units, which have got a much higher airflow rates and all. So it's basically a question of having these units which are higher airflow rates. I think these are solutions which can help to minimize the problem. That's where I look at it. Asking them to retrofit or put anything more than that may not be possible. And all of these solutions should be easily be possible within 1 to 1.5 lakhs of rupees, Dr. Aggarwal.
Thank you. I just want to share one slide, which is uptodate.com is our medical Bible. I mean, we cannot challenge this document. They say that when an AII room is not available, a portable HEPA unit can be placed in the room, although it does not compensate for the absence of negative airflow. This is one line which it talks about, because when we come to a medical legal aspect, this book is the only one which is going to save us, because this is authenticated, which is a reference and which is like a medical Bible. Uptodate.com is a type of a medical Bible for all the doctors all over the world. So this says when AII room is not available, a portable HEPA unit. So I only want to understand technically, what does this portable HEPA unit means? If it is cost effective, then we can recommend it to the doctors and they can safeguard medical legally themselves. Because there are two things. One is medical legal saving ourselves, and second is safety. Because we also need to, if we are practicing without a medical legally safeguarding ourselves, nobody will open up the medical profession today, because they need, somebody gets an infection, will file a case against us that your unit was not compatible. So today we need to recommend, because this reference is available, a portable HEPA unit. What does it mean? That's a medical recommendation all over the world.
Sir, sorry, I don't know whether the question was addressed to all or to Rakeja. I'm just barging in.
No, I want a summary, because it's all of us are going to signature it to the document today. It doesn't matter who's speaking. We are coming out with the guidelines, everybody's name will be there.
Okay, with due permission from Ashish and Dr. Chandrasekhar and all. So we use what is known as FFUs in our immunosuppressed patients' room, like liver transplant rooms or kidney transplant room, fan filter units, which comes with a built-in HEPA. Now that's what exactly we have used when I mentioned that BSL-2 lab, which I mentioned to you a while back. We have used that FFU, which is fed through the ductable split unit, which is there, which is conditioning the space. So the air is coming through a fan filter unit and return is not going back to it. So it is a little bit oversized. And the exhaust is again going through a ducted system, which is going through a UV and then a HEPA. So there is no question of contamination for the person who is inside or the air which is being thrown out. This whole thing will cost about 1.5 to 2 lakhs. I mean, what even Dr. Chandrasekhar was mentioning, same. That is the cost. So that cost has to be incurred. And they can do a culture test before and after to be very sure. And they can keep doing a culture test as often as possible to prove that things are working and it's in safe condition. That's probably the only solution as of now, which also meets your requirement that if in case it is not a AIA mandated room, go in for a standalone HEPA. So this exactly fits into the standalone HEPA.
And what is your Dyson one, the air purifier with HEPA?
The Dyson one is again a HEPA filter only, which circulates the room, which is within the space. It doesn't bring in any fresh air. Now that is still to be experimented. So we haven't done. We are trying that experimentation. Probably in about 2 weeks' time, I should be able to tell you whether it really worked or not worked. As of now, theoretically, they are claiming it should work. And somewhere I also feel that because the air is going through HEPA each time, it should work. But Dyson, as you know, was created to control the air pollution in Delhi. PM 2.5 was the target of Dyson. It was not COVID. Now, COVID being at 0.3 micron, I don't know whether it will trap it. So that's the question. And even if it traps and if it escapes, I don't know what happens to the RNA which comes out, will again further develop into a COVID. These are all little bit concerns we have. So we will conduct RT-PCR on the air samples that we collect, and probably will be in a position to tell in about 2 weeks' time.
So Dr. Aggarwal and Mr. Suresh, I just want to add there, I think important aspect is, look, it is proven that a good HEPA filter can capture the virus. It's there, is all documented, is available.
Okay.
Now the challenge in a room is that if you put a portable unit which doesn't have enough capacity, that means let us say it is changing the air 1 to 2 times in an hour, it is not going to be effective. So you need a portable unit which is changing the air multiple times in an hour, ideally 12 air changes per hour, but obviously having a 12 air change per hour, maybe a fan filter unit can achieve that, but a smaller portable lesser than that may not be able to achieve. So it's a question of achieving higher air change rate. My advice is anything between 6 to 12 air changes if we are able to achieve with this with the portable unit, which is correctly sized, has a proven HEPA filter. That means it is certified HEPA filter, would offer a better protection to the indoor environment and what you are trying to talk about, Dr. Aggarwal. So that's where we'll go. Just putting a small air purifier is not the portable air filter.
No. When I say the recommendation we gave is that if you are in an aerosol room, 12 exchanges per hour, and if you are in a clinic, 6 exchanges per hour, because our contact time is 10 minutes in a OPD and 5 minutes in an aerosol room. So we are talking about a minimum 6 exchanges per hour, air purifier, HEPA filter, and then there are guidelines available how to change the HEPA filter using the PPE. Those guidelines are separately available on those our medical websites. So they normally recommend that 6 to 12 exchanges per hour, air purifier with a HEPA filter, portable unit is a minimum requirement in a clinic where AII rooms are not available. So I was only trying to find out which is the company who can provide 6 exchanges per hour HEPA filter with so much CDR required. And I mean, are they making it in India or not? This is what I have my question.
It's not important that is one company, one unit provided. You can put 2 units, 3 units also. So if you got a good portable unit and put 3 of them in the room, you're getting a better CADR in the process. So it's a selection criteria which we are talking of here. So your guidelines are very clear: 6 to 12 air changes, portable HEPA filter, which you can get even from a portable air cleaner. And if it's a certified HEPA filter in that, you are meeting that. So it's a selection is what it is boiling down to.
But yeah, your killing rate has to be there. With the COVID in mind, you have to have this killing. Nowadays, this portable thing is available with this either UV built or even the plasma. Plasma thing is also absolutely, it is a kill only. Killing is essential. That is mantra in the, COVID. Rest of the thing are absolutely in place. That is no problem. Air changes is a must. That is fine. And the HEPA filter can take care. But you have to have the killing of, viruses. That is essential.
So I will ask Dr. Kalra to, after the meeting, to work on it, to come out with a size of 10 by 15. What is an ideal HEPA filter and what is an ideal plasma filter together. Okay. And then we can come out, those people who can afford, they should do it. I would be the first person to do it in my clinic. The reason being that we need to save ourselves and the public, because this is going to be a future. Because if it is COVID-19 today, tomorrow COVID is 20 is going to come. If the inter-countries relationships are not solved, you are expecting COVID-20 to come anytime, because these are country-made viruses. I'm very sure about it. So let's have Shashank to say final words and then Jailal to close with the final words.
So I think the need of the hour is to develop a clinic-based system, which will be, as Dr. Aggarwal said, a portable AII system, which can be cost effective. And I expect that our domain experts can give 2-3 solutions, which is commercially available, which our doctors across the country can use. Because if those clinics open up, as Dr. Aggarwal said, we will have a solution, and Dr. Kalra will summarize that. I just had one quick question from all the 3 experts. Your final take on ozone air sterilization, and then I'll pass on to Dr. Jailal. He has not spoken at all. I wanted him to summarize it actually. So very quick comment on ozone air sterilization, because in Mumbai, we have all these ozone clubs and they are completely driving us nuts. So any quick comment, Suresh, Chandrasekhar and Ashish?
See, the photohydroionization which we are using, it already has this ozonide. So with the hydrogen, with the same peroxides, etc.
Because there are a lot of ozone air sterilizer available for 15,000 rupees, and a lot of doctors in the clinics in Mumbai city, the general practitioners have put a lot of ozone, air sterilizing units, and they are quite cheap. They are 15,000
unfortunately, rupees. We are driven by these marketing guys.
That's right. That's right. That's why we want to know.
That the technical supports are lacking. If they have the proven this thing, then we can always suggest. Otherwise, ozone is also part of it, which we are being, recommending. Ashish can also throw light on this.
So, Dr. Joshi, I think I fully agree with Dr. Chandrasekhar. Until unless things are better understood, one should not just go by the marketing gimmick. Ozone can be even more dangerous than having it. It can be more dangerous than not having it. So we are actually getting into an area where when Dr. Aggarwal is talking about the medical legal aspects, you're getting into a bigger trouble zone by exposing yourself continuously to ozone, which is a proven carcinogenic. So I would be careful about this thing. I've even seen units. You're talking about ozone. I've seen units where they're saying bring the UV lamp, carry it in your hand, take it over a person, and the person becomes disinfected. I've seen even claims like this. Now, can you carry a UV light in your hands? And what do you do? So things are crazy out there, the solutions which are available. Let's not get carried away.
No, but we also need to have a advisory of warning. So Dr. Aggarwal, when he makes a document, we must have a warning there that all these things should not be used. See, it's equally important because we have a very big business magnate. I don't want to name him. You probably all know him. He runs the Ozone Club in Bombay, and he virtually says everything is nothing but ozone. So we need to actually have some of these red light advisories. Please don't use UV. Please don't use ozone. Yeah. We need to have some of these don'ts also to be spelled out in our guidance. That's the only reason I asked that question. And I think it's important.
I wouldn't say don't use ozone. I think it will be going too far because point is the ozone at the end of the day is if it is within the permissible limits, you can always claim that it's okay. So the tests are available. If we have to use ozone, be careful, get the test done. And if the concentration levels are within the limits, then nobody can say that why you came to me and said the ozone should not be used. So be careful with making.
No. In fact, you should use the same language as recommended by physician when you say for medicine. So as recommended by the expert, you cannot just often take it and say all is well. I have put in a HEPA or a ozone inside, so everything is okay. So you say that proper expertise or knowledgeable people should be involved before getting into any kind of a system. Systems are available. Instead of saying don't, say use it with judicious, with a proper consultation.
Actually, we need a body to certify all these agents. And actually, some of you all should be on the technical committee. Dr. Aggarwal, why don't you appoint a committee to verify these devices by this committee so that they can say it is okay or not okay? That might be another solution.
I'll do that. I'll now, because it's already 12:30, I'll request Dr. Jailal to sum up, close. And maybe outside the meeting, we may take more advice from all three of you when we make a final document.
Definitely.
Thank you very much.
Sanchita, this document will not be published till it is seen by everybody.
Yeah.
It has to be circulated. It has to become a white paper. Okay. Yes.
Thank you very much. And we had a very useful interaction, but this shows us the need for intersectoral meetings like this, because everyone is expert in their own particular field. Only when it is interacting with each other that we are going to get to the problems. And when we know something about that UV light and other system, how it is working, I'm very so happy that Dr. Suresh should be able to put in some more values in that, which are the practical issues which we face. But that has given us a lot of input on this. And when the experts are able to interact with each other, definitely we will be able to come out with the solutions. And the solution has to be in a 3 category. One is for the high-end hospitals like Max or other Apollo hospitals where the facilities are available. There's another also we are seeing that 60 to 70% of our doctors running a clinics or a small size hospital where the requirements and the need is at different level. And third is the most variety is the public hospitals where the government GH and medical colleges where the need is different. So the recommendation has to be also in 3 different levels, which we need to make it so that it will be very useful there. Today, with the market-driven era, not only in the medical field, where even our N95 mask and PPE kits are exaggeratedly, the costs were escalated, the qualities were there is a lot of doubts on the qualities were there, and the N95, KN95, and a lot of other gimmicks are coming in. So we need to have a technical body to consolidate like an ISA standard where this, especially in the COVID era, on the basis of Epidemiological Act, I will request Dr. K.K. Aggarwal sir to use this Epidemiological Act or the era where these issues all related to the COVID management should be certified by an expert committee, which is other than this ISA or other expert committee should be reconstituted. And if that can give a certificate covering both our medical equipments and environmental equipments and equipments which are trying to forbid the air quality, all other things has to be considered. So that shall be also one of our recommendations of this committee, then how we are going to constitute and how we are going to certify. Probably the national board or the NABH can also, Dr. Kalra is there, and whether he will be also help us in that, bringing out the standard guidelines from NABH, which we can also certify, and we can give a stamp of NABH so that it will be very useful for that. But I must congratulate all the experts for giving your expert views and interacting and responding to the questions in an appropriate way and putting it across so that we, the general practitioners, we are dealing with the people will be definitely benefited with the interest of the safety of our doctors as well as the safety of the public who are coming to our hospital. So we are looking forward, the entire country is looking forward to get a clarification, get a final outcome from this meeting. And I'm sure it will be a great torchbearer to the future of the COVID care, which we are going to live along with us. So I take this opportunity once again, thanks as usual our Bhishma Pida and Padma Shri Dr. KK for that initiation and the expert guidance for the last whole era of this COVID pandemic. He has become a guru for COVID for all of us, the medical fraternity in our country. And also Dr. Shashank, who is the hero of in Dharavi and Bombay, where he has proven a lot of effort, where the Indian doctors can make a lot of change, which he has proven. So all of you have put in a lot of values. Thank you very much for this opportunities.
Before I close, I have a small request. I want Dr. Jayalal, Suresh ji, Upasna ji, and Shashank ji, who are handling patients. So I need a small study of 25 people each, which I want all of us to present next time. So I want to have a screening of a patient who is coming to a hospital with 4 things. I'm not talking about a COVID hospital. In a non-COVID hospital, in a non-COVID facility, 4 things to be checked. One is taste of jaggery. Number 2 is smell of a rose. Number 3 is SpO2 level. Number 4 is temperature. Instead of temperature, which we are checking, I want these 4 things to be checked. And to pick up, do we pick up some asymptomatic or some patients of COVID in a non-COVID facility? Normally, we are checking only temperature. So I want to add 5 parameters. 5th parameter is hand grip. Hand grip, because the hand grip may be low, you may be feeling weak, and lower hand grip. So 5 parameters to be checked of 25 doctors each, 25 patients each. So we have south, east, north, everywhere. And if we can have the data discussed next time, we can come out with a very good study.
Sure, sir.
Because I'm talking about 5 parameters.
Yes, sir.
Taste is good ka taste. Good is jaggery, is sweet taste. Smell of a rose, SpO2 level. 4th is hand grip, and 5th is temperature. And if any one of them is positive, we presume it to be a COVID positive. So can we pick up with these screening parameters? Because that will answer us a lot of triage. When you're talking about social engineering, in the social engineering, these 5 factors will help us a lot in picking up at least 10 to 15% extra patients.
Sure.
Dr. Kalra, I would like you to make it official and send it to everybody. So if we can have a data of 25 doctors, 25 patients each, we will have a 125 pan-India data. And even if we come out with 5 to 7% extra patients, this can become a universal screening method all across the world. Thank you, everybody, for being here. We'll see you next week. Thank you.
Thank you, Dr.
I need to further interact with some domain experts for deciding the practical solutions for small clinics and nursing homes.
So Joel, you can continue. You will
Dr.
continue.
Kalra. Thank you so much.
I'm signing off. Thank you.
Yeah, thank you.
Thank you, everyone.
I will send you Dr. Kalra. Yeah.
Please.
Thank you. Bye-bye.
Thank you. Bye-bye.
Bye-bye. Suresh ji, probably we need to discuss further at length the practical. You have done a lot of practical work.
We can catch up.
Solutions. Probably we can work out for major hospitals as well as for these. We need to discuss again. Yeah.
Awesome. We will.
Thank you.
Welcome, sir.